Hi, this is Team Tan. Today, we're going to talk about the predicting beauty product success at Sephora, a challenge that every retailer faces when deciding which product to invest in. So let me start with our key findings. First, we discovered that the perfect accuracy actually signaled overfitting when a model memorized the training data rather than learning the true patterns. Second, the logistic regression merged as our champion because it balanced the strong performance with generalizability. And second, the hybrid feature engineering was the solution that fixed our overfitting problems and gave us reliable predictions. So, the core business question we're addressing here is, can we actually predict the product success before it launched? This is harder than it sounds. The main challenge here is that we need to make the decision 6 to 12 months before a product hit the shelf. At that point, we have no rating, no customer reviews, and no sales data, only the product's inherent features like the brand, price, categories, ingredients. An approach involved analyzing 8,494 products across 304 brands. We compared the three models, that is logistic regression, random forest, and XG boost. Importantly, we prioritized the generability over the raw accuracy because the model that performed perfectly on the past data but fails on the new product is worthless for business decisions. This brings us to the business impact. Our final model delivered a realistic prediction that buyers can actually trust for inventory decisions. This is interpretability, showing the buyer should why should a product is predict to succeed or failed. Also, this is generalizable, working reliably on new brands that model have never seen before. And critically, this is deployable it ready to integrate into the product system today.
So I'm Sakhi and I'll walk you through the baseline model we built, how more complex models behaved, and why logistic regression ultimately became the best choice for real world forecasting. I'll start with our baseline model, which is logistic regression. Using only pre-launch features like price, brand history, category strength, and a few engineered flags, this model achieved about 70% accuracy and 94.5% recall. Now, recall is particularly important because the cost of missing a bestseller is much higher than the cost of incorrectly predicting success. The model identifies the key drivers of success clearly. Strong brands and strong categories tend to do better, while completely new products carry higher risk. This baseline serves as both our starting point and a benchmark for comparison. So next, we evaluated two tree-based models, random forest and XGBoost, which are commonly used for structured tabular data. Their accuracy numbers initially appeared extremely strong. Random forest reached about 98%, and XGBoost even reached 100% accuracy on the test set. However, when we look deeper, these results immediately raise concerns. Both models achieved over 99% accuracy on the training data, which is a textbook sign of severe overfitting. Essentially, these models weren't learning generalizable relationships. Instead, they were memorizing the historical patterns in the data set. When we examined feature influence and decision paths, we found that the models relied almost entirely on brand level and category level historical success rates. This led to overly simplistic rules such as if this category historically performs well, classify as successful. These rules work extremely well on past data but do not hold when conditions change, such as when a new brand enters a category for the first time or when consumer trends shift. Even though we used leave one out feature construction to avoid leakage, the trees model still locked on to the past in ways that made them unreliable for forward looking prediction. So, despite their near perfect accuracy, these models would likely perform poorly in real deployment. So this brings us back to logistic regression, which we selected as the final model for deployment. Although its accuracy is more modest, it provides far better generalization, especially when predicting products from new brands or from categories without strong historical patterns. The model is also more stable and less sensitive to small shifts in the feature set, which is important because product assortments change continuously. Logistic regression also achieved excellent recall, meaning it successfully identifies most potential bestsellers. From a business perspective, this is crucial. Failing to stock a bestseller is far more damaging than carrying a few lower performing products. Another important advantage is interpretability. Retail teams need to understand why a model recommends a product, especially when millions of dollars in buying decisions are involved. Logistic regression gives you clear directional insights that can be explained to non technical stakeholders. So, overall, logistic regression provides the best balance between performance, interpretability, and real world reliability, making it the most appropriate model for pre launch forecasting. So, in summary, while complex models achieved higher accuracy, their performance was driven by overfitting. Logistic regression offered realistic, stable predictions and clear interpretability, making it the best choice for practical deployment. Thank you.